We're about to talk about the piston, but first I shall colour in my table and try and hide all these scratches that we've made so far. Welcome to Hollywood. We've installed the crankshaft, now we're ready to install the pistons. This is a piston assembly. A piston assembly consists of the piston, which is this shiny part at the top, which runs up and down the cylinder, the connecting rod, which connects the piston to the crankshaft. Around the top of the piston here we have some piston rings, and we also have a wrist pin, which is this tubular section which connects the piston to the connecting rod. And the very bottom of the connecting rod here is the rod cap, which detaches in order that it fits around the crankshaft. So we can pull that off, and there is the rod cap. We'll get on and talk about all these parts in more detail. But before we do that, it's important to say that the piston has lots of ongoing development with it. It's not just a completely finished engine component in terms of development and evolution. About 60% of the engine's power gets lost in friction in this piston assembly. So any improvements to that make a huge difference to the power output of an engine. That said, let's take a closer look, starting with the piston. So the piston is a movable plug basically. It moves up and down inside the cylinder. It creates a gas-tight seal. You can think of it like a cannonball being fired out of a cannon, except instead of firing off into somebody's ship, it goes down, the crankshaft spins around, and it comes back up. This top surface of the piston is called the crown, and that forms the bottom of the combustion chamber. It's the hottest part of the piston. It gets extremely hot on the combustion stroke. There can be various shapes of crown. There's a dished crown, a domed crown, or a flat crown, depending on the shape here, and those are used for different applications. The valve recesses, these areas here, these four areas that you can see, are recesses for the valves to fit into, create some clearance around the valves. And the crown expands more because it gets hotter than the rest of the piston. So there'll be a slight taper on the edge of the piston here towards the top, and the crown will be ever so slightly smaller than the remainder of the piston. So these side parts of the piston are called the skirt, and these form a smooth surface that runs against the cylinder wall. And the reason we need a skirt in the first place is that as the piston moves up and down in the cylinder, we have side-to-side forces. So not only do we have up and down motion of the piston in the cylinder, we also have, if you see, as the connecting rod takes an angle here, and the crankshaft is rotating round, the connecting rod will always be moving from side to side. Once it's at an angle, if I push down on the piston here, you can see that the piston wants to move to the side. And so we need the skirt to form a contact surface against the cylinder wall and stop this motion of the piston, because we want to lock this piston exactly like this and then move up and down in this motion. So that's the purpose of the skirt. There's different types of skirt. You have a full skirt, which is basically a tubular piston with a skirt coming all the way down. Or in this case, what we have is a slipper skirt, which is where the sides here are removed. Almost all modern car engines will use a slipper skirt design because these parts of the skirt are not needed to prevent this side-to-side movement. And so we can eliminate them, we can reduce the weight, and we can reduce the friction on the cylinder wall. And generally, we want the piston assembly to be as light as possible. That cuts down on momentum. As this piston is moving up and down 15 times a second minimum, really, there's an enormous amount of inertia at the top and the bottom of this stroke, and that creates huge forces inside the engine which don't necessarily help us with power. So if we can keep the weight in this assembly down to a minimum, no surplus material, nothing that's not needed, then that's a great benefit to the performance of the engine. Hopefully we're going to add some CGI to show this, but what we've got is one face of this piston is called the thrust face. And what happens is, as the piston is moving around, on the combustion stroke, which is the stroke that forces this down, on that stroke, the piston will be moving against the wall, and that stroke is the one with the force. And so as the piston, for example, we're here, and as we push down here, this face that wants to contact the cylinder wall is called the thrust face. As we push down here, you can see that this particular face will have a much more force on it than any other face on this particular stroke, and that's called the thrust face. That can cause wear on this surface of the piston, or indeed on the cylinder wall there, that will be the most wear inside the cylinder. The other thing that you might find on pistons, most pistons rolling off the production line today will have a low friction coating on the face, or one or more of the faces of the piston. And that's basically like a non-stick coating on your frying pan or a Teflon surface. That just cuts down on friction on these faces that contact the cylinder wall. Again, greater efficiency inside the engine. The piston has a very snug fit inside the cylinder, so there's around 0.1 of a millimeter gap between the piston and the cylinder wall. That's around 0.04 of an inch. And that gap, if we just left it, would allow combustion gases to get past the cylinder into the crankcase and oil potentially to come past the piston into the combustion chamber. And both of those things we absolutely don't want. So if you take a look towards the top of the piston here, you can see we have 3 grooves, and into those grooves fit piston rings, which are there to take up that clearance, to bridge that gap and to create a gas-tight seal. So let's take a closer look at those. The grooves are unsurprisingly called grooves, and the spaces between the grooves are called lands. And this very top space at the top of the piston between the top piston ring and the crown is called the headland. Now, piston rings, we've got some here on the bench, fit into these grooves. We've got a video on installing piston rings, so rather than show you that fiddly process, here is a piston with the rings installed. This piston, like most pistons, has 3 rings. The top 2 rings are called compression rings, and their job is to maintain a gas-tight seal, to take up that clearance between the piston and the cylinder wall. They get the name compression rings because they maintain the compression inside the combustion chamber. Those rings are forced out against the piston wall by their natural springiness. They're helped by the gas, which on the combustion stroke makes its way in behind the ring and forces it outwards against the cylinder wall. So the top 2 rings maintain the compression and the gas-tight seal, and the job of the bottom ring here, which is a different style, is to control the film of oil on the wall. So it's called the oil control ring, and the job of that is to make sure that we have an even, perfectly formed film of oil on the cylinder wall for everything else to run on. The oil control ring is made of 3 parts, usually, or formed of 3 different rings. We've got at the top and the bottom, we have very, very thin rails, which are thin rings which form the top and bottom and scrape the oil off. And then in the middle we have a spacer, which has sort of hollow cavities there, which allow oil to run into this groove. And then inside the groove, unlike the other 2, we have 2 drain holes, and that lets the oil, the excess oil that's been scraped off, drain back down the cylinder and into the crankcase. Controlling the oil inside the cylinder is vital, because with too much oil, we'll end up with oil inside the combustion chamber, which causes poor running and excessive emissions. It creates a greater buildup of carbon inside, so generally these are all bad things we don't want. Likewise, too little oil on the cylinder wall and we'll end up with metal-to-metal contact, which causes wear, expansion, excess heat, and so on. So the oil control ring has a very important job inside the engine. Now let's talk about the connecting rod. That's the part that connects the piston to the crankshaft. So this connecting rod is still connected to the piston. I would like to show them separately, but the connecting rod is connected to the piston through a tube, which is called the wrist pin or the gudgeon pin. And there's 2 different types of gudgeon pin, or 2 different types of attachment. This one, the pin is pressed into the piston, and to get that out requires the use of a press, and it frequently can damage or bend various parts. So I haven't disconnected them because it seems a little bit pointless to do that just in order to show the connecting rod on its own. There's another type of connection which is called a fully floating pin, which is where it's held in with circlips, and the connecting rod and the piston are both free to float on the pin. This one, where it's pressed into the connecting rod and the pin move as one part, that's called a semi-floating design. The connecting rod, on every stroke, the piston is being forced down, and every stroke is trying to squash, stretch, or bend the connecting rod. So it needs to be enormously strong. That's why it uses an I-beam shape. It's like a miniature girder that holds up a skyscraper or a bridge or something. It has the same requirement for maximal strength and minimal weight. And that requirement for strength means that the connecting rod will be made of a strong material, typically forged steel or sintered steel, or in fancy performance racing engines, titanium. So the parts of a connecting rod are really quite simple. We've got at the top a small eye that the wrist pin fits through. That's called the small end. At this end we have a big eye, which is called the big end, and that fits around the crankshaft. Then we also have on the end this separate piece, which is called the rod cap. So we fit this onto the crankshaft, install the bearing inserts, install the rod cap, and then tighten that down. And that creates the clearance around the rod journal. The big end of the connecting rod is wrapped around the crankshaft and is lubricated by a feed of oil that comes through the crankshaft into here. As we'll have some bearing inserts. These are called the big end bearings. These fit inside this shell, and oil makes its way inside to fill that clearance. On some connecting rods, there'll be a passageway drilled through the connecting rod itself to a hole which comes out somewhere up the connecting rod, and that allows oil to flow in a sort of stream onto the cylinder wall, or indeed onto the underside of the piston. On this particular connecting rod, we don't have a hole that runs through an oil way for the oil, because the underside of the piston is cooled by an oil jet which is fixed to the engine block. Now let's install a piston into the engine.